Azure Virtual Networks, or VNets, serve as the cornerstone of your private cloud infrastructure within Azure. They provide a logically isolated environment, ensuring that your Azure resources operate within a dedicated and secure network segment. This isolation is fundamental for maintaining data integrity and compliance. VNets empower you with granular control over your network topology, allowing you to define custom IP address spaces and segment your network into subnets. This precise segmentation enhances security and optimizes traffic flow. Furthermore, Azure VNets are the foundational layer for all secure communication, enabling seamless integration with your on-premises networks through hybrid connectivity, facilitating secure communication between different VNets via VNet peering, and supporting a wide array of advanced networking services crucial for robust enterprise deployments. When designing your Azure virtual networks, diligent attention to IP addressing and subnetting is paramount. Our first principle emphasizes the strategic selection of VNet CIDR blocks. It is critical to choose IP address ranges that meticulously avoid any overlap with your existing on-premises networks or any other peered Azure VNets. Furthermore, always reserve ample address space within your VNet to accommodate future expansion, preventing the need for complex re-architectures later. Our second principle advocates for implementing logical subnetting. This means segmenting your VNet into smaller, dedicated subnets based on application tiers, security zones, or distinct functional roles. This practice significantly enhances security through granular network security group rules, improves performance by localizing traffic, and vastly simplifies network management. Finally, our third principle underscores the importance of planning for future growth and scalability. When allocating your subnet ranges, always consider allocating larger blocks than what is immediately required. This foresight accommodates new services, unforeseen resource demands, and general organic growth, ensuring your network infrastructure remains robust and adaptable over time. VNet peering is a fundamental Azure networking capability that facilitates the private connection of two Azure virtual networks. This feature is particularly crucial for establishing secure and high-bandwidth communication between VNets located in different Azure regions or even across distinct Azure subscriptions. When VNet peering is implemented, the virtual networks behave as if they are a single, cohesive network, enabling resources in one VNet to communicate directly and privately with resources in the peered VNet. The data transmission between peered networks occurs entirely over the Microsoft backbone infrastructure, completely bypassing the public internet. This architecture ensures low latency, high throughput, and enhanced security for inter-VNet communication. It eliminates the need for complex VPN gateways for simple VNet-to-VNet connectivity, streamlining network design and management for globally distributed applications and services. Azure VPN Gateway is a critical component for establishing secure hybrid connectivity between your on-premises networks and Azure virtual networks. It facilitates the creation of encrypted IPsec and IKE VPN tunnels over the Internet, effectively extending your corporate network into the cloud. This integration allows resources located in Azure to communicate privately and securely with on-premises servers, applications, and databases as if they were part of the same contiguous network. Key benefits include secure data transfer, enabling hybrid application deployments, and providing access to Azure services from on-premises without exposing traffic to the public internet. The VPN gateway acts as a bridge, ensuring robust and reliable private connectivity essential for modern enterprise architectures. Network security groups, or NSGs, are fundamental components for managing network security within Azure. They implement stateful packet filtering, a critical capability that involves tracking the active state of network connections. When an NSG processes a packet, it not only evaluates the packet against defined rules, but also maintains a record of established connections. This stateful awareness means that if an outbound connection is initiated from an Azure resource, the NSG automatically permits the corresponding inbound return traffic for that specific established session, without requiring an explicit inbound rule. This mechanism significantly enhances security by ensuring that only legitimate, solicited traffic related to active connections is permitted. NSGs provide granular control through configurable rules, specifying source, destination, port, and protocol for both inbound and outbound traffic flows, applying these controls to network interfaces or subnets. Network security groups, or NSGs, are a fundamental component of Azure's network security, enabling fine-grained control over network traffic. Inbound security rules govern traffic destined for Azure resources, specifying permissible source IP addresses or ranges, destination ports, and protocols. Conversely, outbound security rules control traffic originating from Azure resources, defining where that traffic is allowed to go, again by destination IP, port, and protocol. Each rule is assigned a priority, with lower numbers processed first. Rules are evaluated sequentially, and the first rule that matches the traffic determines the action, either allow or deny. Crucially, if no explicit rule matches, an implicit deny all rule at the lowest priority ensures unpermitted traffic is blocked, enforcing a robust security posture. Application Security Groups, or ASGs, are a fundamental feature designed to simplify network security management within Azure. They enable you to logically group virtual machines by their function, such as web servers, application servers, or database servers, regardless of their IP addresses or even their specific subnets. The primary advantage of ASGs lies in their integration with network security groups. Instead of defining NSG rules based on explicit IP addresses for individual virtual machines or IP ranges, you can directly reference an ASG name within your NSG rules. For example, you can create a rule that allows inbound HTTP traffic to the web server's ASG, or restricts outbound traffic from the application server's ASG to only the database server's ASG. This approach significantly streamlines security policy management. When new virtual machines are provisioned and added to an existing ASG, they automatically inherit all the associated NSG rules. Conversely, if a virtual machine is removed or its function changes, updating the security policy involves merely adjusting its ASG membership, not modifying numerous IP-based NSG rules. This dynamic and group-based approach enhances scalability, reduces administrative overhead, and minimizes the potential for configuration errors. Azure Load Balancer is a fundamental component of Azure's core networking services, operating at Layer 4 of the OSI model, specifically the transport layer. Its primary function is to distribute incoming network traffic across multiple healthy virtual machines or services within a backend pool. This distribution is based on hash-based algorithms, utilizing source IP, source port, destination IP, destination port, and protocol. By abstracting the backend infrastructure, Azure Load Balancer ensures high availability and improved application performance by eliminating single points of failure and enabling applications to scale to meet demand. It supports both public load balancing, directing internet-facing traffic to resources within a virtual network, and internal load balancing, distributing traffic within private IP addresses for internal applications. This service is crucial for building resilient, scalable, and high-performing applications on Azure. Azure Load Balancer offers two distinct SKUs, Basic and Standard, each tailored for different operational needs and scalability requirements. The Basic SKU provides foundational load balancing capabilities suitable for smaller-scale, non-critical workloads with limitations such as no zone redundancy and integration with availability sets only. In contrast, the Standard SKU is designed for robust, enterprise-grade applications, supporting zone redundancy for higher availability, advanced features like high-availability ports, and comprehensive integration with Azure Monitor for detailed metrics and alerting. Crucially, the Standard SKU enables the implementation of health probes. These probes are critical components that continuously monitor the health and availability of back-end instances within a load balancer pool. By regularly sending requests to configured ports or paths, health probes determine if an instance is responsive and operating correctly.
Should an instance fail to respond, the load balancer automatically removes it from the rotation, preventing traffic from being directed to an unhealthy server. This ensures that only healthy instances receive traffic, thereby maintaining application availability and providing a seamless user experience even in the event of individual server failures. This proactive management of back-end resources is fundamental to achieving high reliability in your Azure networking infrastructure.
Azure DNS provides a highly available and scalable domain name system service within the Azure ecosystem. It allows organizations to host their DNS domains directly within Azure, leveraging Microsoft's global infrastructure for unparalleled reliability and performance. This service enables efficient management of DNS records for all your cloud resources, ensuring seamless name resolution for applications and services deployed across your Azure subscriptions. By integrating natively with other Azure services, Azure DNS simplifies the process of connecting users to your applications, databases, and virtual machines. Its robust architecture minimizes latency and maximizes uptime, forming a critical component of a resilient and interconnected cloud networking strategy. Azure Private DNS Zones offer a critical service for managing internal namespaces within your Azure environment. This managed DNS service allows for seamless name resolution within virtual networks without the need to deploy and manage custom DNS solutions. It provides a secure and reliable method to resolve domain names for virtual machines and other resources residing in your virtual networks, ensuring that these internal names are never exposed to the public internet. Key benefits include simplified DNS management, automatic registration of virtual machines within linked virtual networks, and the ability to resolve names across peered virtual networks. This capability is fundamental for streamlining operations, enhancing security posture by keeping internal DNS traffic private, and ensuring efficient communication among your Azure resources. Azure Public DNS Zones provide a highly available and scalable solution for hosting your organization's external domain names. While Azure Private DNS Zones handle internal name resolution within your virtual networks, Public DNS Zones are specifically designed to manage domains registered with third-party registrars, making them accessible from the public internet. This service enables you to configure and manage all standard DNS record types, including AAA, CNAME, MX, SRV, TXT, NS, and SOA records for domains such as yourcompany.com or yourproduct.net. By leveraging Azure Public DNS Zones, you gain a fully managed, robust, and secure DNS service that eliminates the need for you to manage your own DNS infrastructure. It offers seamless integration with other Azure services, providing a centralized and efficient platform for all your public-facing DNS requirements, ensuring your external services and websites are reliably discoverable globally. Virtual network service endpoints represent a critical security feature within Azure's core networking capabilities. They extend your virtual network's private address space to directly connect with Azure Platform as a Service, or PaaS, resources such as Azure Storage, Azure SQL Database, or Azure Key Vault. This direct connection ensures that traffic from your virtual network to these PaaS services traverses the Microsoft backbone network, bypassing the public internet entirely. The primary benefit is a significant enhancement in security. You can configure your PaaS resources to only accept traffic originating from specific virtual networks and subnets, effectively isolating them from public access. This not only bolsters your security posture, but also simplifies your network architecture by removing the need for complex firewall rules or VPN gateways for PaaS access within your VNet. Service endpoints provide a robust and secure method for consuming Azure PaaS services while maintaining a private and controlled network environment. Azure Firewall is a cloud-native, intelligent network security service designed to provide centralized network security across all your virtual networks and subscriptions. It offers a fully stateful firewall as a service with built-in high availability and unlimited cloud scalability. This service ensures that all inbound and outbound network traffic is securely filtered and monitored. Azure Firewall integrates advanced threat intelligence from Microsoft Cybersecurity providing real-time protection against known malicious IP addresses and domains. Its capabilities include URL filtering and FQDN filtering, allowing precise control over network access based on fully qualified domain names and specific URLs. Furthermore, it provides extensive logging and analytics capabilities through integration with Azure Monitor, enabling comprehensive visibility into network security events. This robust solution is critical for maintaining a strong security posture and adhering to compliance requirements within your Azure environment. Effective monitoring is paramount for maintaining the performance, availability, and security of your Azure network infrastructure. Azure provides two powerful services tailored for this purpose: Azure Monitor and Network Watcher. Azure Monitor serves as the foundational monitoring solution, collecting and analyzing telemetry data from all your Azure resources, including network components such as virtual networks, load balancers, and gateways. It offers comprehensive insights into network performance, health, and utilization through its logs and metrics, enabling you to set up alerts and dashboards for proactive management. Complementing this, Azure Network Watcher provides a suite of specialized diagnostic and visualization tools designed specifically for troubleshooting and gaining deeper insights into your network. Features like Connection Troubleshoot, IP Flow Verify, Nextop, and NSG Flow logs allow for granular inspection of network traffic, security group rules, and connectivity issues. This enables rapid identification and resolution of network-related problems. Together, Azure Monitor and Network Watcher offer a robust, integrated approach to ensuring your Azure network resources operate optimally, providing the visibility needed for continuous optimization and robust incident response. Adopting best practices is crucial for secure and efficient Azure networking. First, implement multi-layered security. This involves deploying Azure Firewall at the network perimeter for centralized ingress and egress traffic filtering, complemented by network security groups, or NSGs, for granular control over traffic to and from individual subnets. This combined approach significantly reduces the attack surface. Second, optimize your network topology by leveraging virtual network peering. This establishes a direct, private, and high bandwidth connection between Azure virtual networks, eliminating the need to route traffic over the public internet, thereby enhancing both security and performance. Finally, ensure proactive monitoring and logging. Utilize Azure Monitor to collect and analyze telemetry data across your network, and deploy Network Watcher for diagnostic and troubleshooting capabilities. These tools provide real-time insights into network performance, enable the detection of security anomalies, and support compliance requirements. Moving to common Azure networking troubleshooting scenarios, 3 areas frequently require attention. First, connectivity failures encompass diagnosing issues with crucial components like VPN gateways, express route circuits, or VNet peering. These disruptions prevent seamless communication between resources, both within Azure and between Azure and on-premises environments. Second, performance degradation refers to identifying and resolving bottlenecks, high latency, or low throughput. These issues directly impact application responsiveness and user experience. Comprehensive monitoring and analysis are essential to pinpoint the root cause, whether it is related to network saturation, resource limitations, or inefficient routing. Finally, security policy misconfigurations are a common challenge. Incorrectly configured network security group rules, Azure firewall policies, or user-defined routes can inadvertently block legitimate traffic, leading to application outages or inaccessible resources. Systematic review of these policies, coupled with Azure's diagnostic tools, is critical to ensure both security and operational functionality. We now open the floor for any questions pertaining to the Azure Core networking concepts discussed in Module 3. Your insights and inquiries are valuable for solidifying understanding of these foundational services. As we conclude this module, our journey continues with Module 4, which will delve into Azure network security and monitoring. This upcoming segment will explore critical aspects of safeguarding your cloud infrastructure and ensuring operational visibility. We encourage you to further explore the provided documentation and resources to deepen your expertise in Azure networking. Thank you.